Car travels for 42 minutes at 36 miles per hour on a dirt road and then 120 miles at 77 miles per hour on the highway. A. How far did the car travel? B. What was the duration of the trip? C. What was the car's average speed during the trip? I've made a position time graph of the trip to bring out the essential points of this problem and what we're looking for. So what we see here, the green line is the position time plot for the car. Over the first leg of the trip, it's got a slope of 36 miles per hour, duration of 42 minutes, and the distance traveled is not specified. We could read it right off the graph if we've plotted this carefully, or we could solve it mathematically. For the second leg of the trip, we know the slope, 77 miles per hour, the velocity. The total distance traveled in the first part of the trip is not given to us. What we are given is the duration and the speed. Using the average velocity equation, delta x over delta t, the unknown here, the desired unknown, is delta x, the distance traveled. So we'll solve for delta x. We get delta x equals v delta t. Plug it in, 36 miles per hour times 42 minutes. Units don't work, so we need to convert the minutes here to hours. We do this with the conversion factor, 1 hour divided by 60 minutes equals 1. When the dust settles, 25.2 miles is the distance traveled in the first leg of the trip. Add that to the 120 miles traveled in the second leg of the trip, and we get 145.2 miles traveled total. Duration is done much the same way. Here, the first part of the trip we're given is a duration of 42 minutes. We'll convert that to hours to get 0.7 hours. The second part of the trip, the duration is not given to us. We have to solve that. Again, using the average velocity equation, delta x over delta t, we want to solve for our desired unknown, which this time is duration delta t. That gives us delta t equals delta x over v average. Our delta x in that leg of the trip was 120 miles. The velocity in that leg of the trip was 77 miles per hour. Do that division, we get 1.558 hours. So now add these two durations of the two legs of the trip together. 0.7 plus 1.558 hours gives us 2.258 hours. Now we have everything we need to find the average speed of the entire trip. 145.2 miles divided by 2.258 hours gives us 64.3 miles per hour. Notice this is not the simple arithmetic average of the speeds of the two legs, 36 miles an hour and 77 miles per hour. That only works if the travel at those speeds was carried out for the same duration of time. In the general case, we can't rely on that. In this particular case, that doesn't happen. So we can't just arithmetically average the two speeds. We have to use the definition of the average speed, delta x over delta t. That will never steer us wrong.